Alright, so similar to everything that we've done so far, we're going to take a look at diminishing or reducing depreciation, also as a recurrence relation. Okay, so not just as a formula to get the nth value, but thinking about it recursively, so what's happening to get to the next value each time. So in general, where we've got a recurrence relation, this is going to look very familiar. This is the exact same as compound interest right here. Okay, so Vn, so that is R times Vn minus 1. Now here's the difference, right here, okay, where that compounding factor is 1 minus R over 100. Okay, so if we're decreasing by 20%, this will end up being 0.8. So if we're decreasing by 20%, we're keeping 80%. So you could write that in one big formula, Vn 1 minus R over 100 times Vn minus 1. Okay, so taking the previous value, multiplying it by the percent that you're keeping to get your next value. So let's give this a try. We've got a car and it's purchased for $25,000. It depreciates at 20% per year. Notice I haven't said what type of depreciation, because I've kind of broken it into two parts. So part 1, set up a recurrence relation if it is reducing rate depreciation. Okay, so what we're looking at right now. Well, that means that our compounding factor, well, it's going to be 1 minus 20 over 100, or 0.8. Again, you can come up with the fact, because I'm losing 20%, I'm keeping 80%. So I'm going to be multiplying by 0.8 each year. So that means that my Vn is 0.8 times Vn minus 1. Of course, we're going to be complete because it's a recurrence relation, and say where it starts at 25,000. Okay, so if I'm decreasing by 20% each year, that means to go from one row to the next, I'm going to be multiplying by 0.8. Okay, now part B says, well, actually, what if it was flat rate depreciation? So how much am I going to be losing each year? And remember, it's going to be the exact same amount every year. Quick refresher for this one, Vn is Vn minus 1 minus D, where D is the amount that we're losing. So D was V0 times R over 100. So if we put that all together, well, how much am I going to be losing each year if I'm losing 20% of that original value? Well, that means D is 25,000 times 20 over 100. So D is equal to $5,000. So I'm going to be losing $5,000 each and every year. So my final equation, box around this one, so that was my recurrence. If I'm looking at diminishing, if I'm looking at flat rate, I'm going to be losing $5,000 each year, and starting with 25. Sorry, running out of space a little bit. Okay. So those are the two different scenarios. Here, multiplying by 0.8 each time. Here, subtracting 5,000 each time. So now let's see how these two compare and how much really the difference is between the two methods. So we're going to set up a table for the first 5 years using both methods. So the flat rate, we started with $25,000 in year 0. Okay? And then each and every year my recurrence relation says I subtract 5,000. So 25 minus 5 is 20, minus 5 is 15, minus 5 is 10, minus 5 is 5, and finally 0, because each time to get to the next value we subtract 5,000. These look like 6s. Okay, so each time to get to the next value I subtract 5,000. And it's a little bit different here. I'm not subtracting 5,000 each time, but I'm multiplying by 0.8. Now the first value will be the same. Okay, so if you want to trust the calculation, 25,000 times 0.8, that is $2,000. Okay, so that is that one, sorry, $20,000. That one is the same. But now when I go to the next value, I'm not taking off the same amount. I'm only going to take off 20% of 20,000. So now I do 20,000 times, sorry, got an extra 0 in there, 0.8. That gives me 16. So the first time I took off 5,000, this time I'm taking off an amount of 4,000, which is 20% of 20,000. Sorry, keep clicking the wrong one. Okay, so this time I get down to 16,000. Now taking 20% of 16,000. So 16,000 times 0.8, I get 12,800. And if I keep going, I get 10,240 and then 8,192. So a massive difference depending on which method we're using. So for the flat rate, after 5 years, it's at 0, so it's being written off, whereas using the diminishing, we're still at over $8,000, so a massive difference there. So just kind of a follow-up to be able to visualize this. I'd like you to use the CAS to plot both graphs on the same axes. Remember, flat, that's an arithmetic, so it's going to be a straight line, versus diminishing, okay, that's geometric, so that's going to be a curve. So I've done a little bit of magic beforehand. Okay, so setting up, I've put in n from 1 to 5, flat and diminishing. So I've got all those values put in there. So if I want to make a graph here, add a page, make it a data and statistics. On this axis, we want n. Pick one to start here. Let's start with the flat one. Good, and that's forming a straight line as it should, so it's going straight down there, forming a nice solid line. Quick refresher, once you're clicked on this axis, okay, so you're on that axis, you can do Control menu. Oops. Again, I would like to add another y variable. I would like to add diminishing. Okay, so you can see the difference. They start off the same, and then the diminishing starts to flatten out. It's curving, whereas the flat just keeps going straight down. Okay, so really notice that curve compared to the line and how much slower it does depreciate by. Okay, so let's take a picture of that. So we can see the massive difference both from the table of values, seeing how much quicker it gets to 0, but that also comes through in the graph. You can see the linear versus the exponential decay. So that's the idea with recursive or recursion with the diminishing.